You know, when you start thinking about learning Python, it can feel a little bit like you're staring into this vast, sprawling landscape.
Yeah, totally.
And it's a little intimidating. You've got web development, data science. It feels like it does everything. And you just want to
Yeah,
figure
can
out,
I even start, right?
right, where to start. What are the key pieces? What are the things I need to know without feeling completely overwhelmed by it all?
Yeah, for sure. I mean, there's just so much buzz about what Python can do.
Yeah,
It's easy to get lost in that and lose track of, well, what are the basic concepts?
exactly. So for this deep dive, we're going to try to cut through some of that noise for you. We're going to take a look at Fabrizio Romano's Learn Python Programming Second Edition.
Oh, nice.
Think of this as your cheat sheet, your guided tour through the most important.
Shortcut, yeah.
Yeah, a shortcut, exactly. To understanding Python, we're going to pull out the most crucial, the most interesting parts of learning Python from this book. And the goal is really to give you that solid foundation in the language and a sense of why it's so powerful.
Yeah, and just to jump in, just looking at this book, Romano really covers a lot of ground. I mean, he starts with
I have a big one.
yeah, he starts with those very basic concepts.
The fundamentals.
Yeah, like how does programming actually work at its core? What are those building blocks that Python gives you? Then he gets into the nitty-gritty.
Yeah.
How do you make your code flow? How do you write those logical instructions? And then really interesting stuff like how to make sure your programs run efficiently.
Oh, yeah, that's key.
Yeah, saving time and memory, all that good stuff.
Yeah.
But that's not all, right?
No, we're just getting started.
That's just the beginning.
Yeah. So he gets into object-oriented programming,
Oh, yeah, that's a big one.
which is really a different way of organizing and structuring your code. And then,
More complex code.
yeah, exactly, for those more complex programs. He even gets into these things called decorators,
Oh, yeah.
which can, you can almost think of them as like adding superpowers to your functions.
Oh, little enhancements.
Enhancements, that's a better word.
There you go.
Then really practical stuff, like how to work with files, save data, how to test your code.
I mean, if your program doesn't work,
Right, what's the point?
you have to be able to test it.
And then, this is where it gets really interesting, he gets into how to run code concurrently, multiple things happening at the same time.
Like a real program.
Like a real program, yeah. And even a peek into building those visual interfaces, those graphical things you click on. And he even touches on data science and web development using Python.
So we're covering a lot here.
We are.
But what we really want you to walk away with is that strong understanding of like the underlying ideas,
Mm-hmm.
why Python is so valuable.
Mm-hmm.
And I think what Romano does so well is he emphasizes not just the mechanics,
The how-tos.
the how-tos, yeah, but the why,
Mhm.
What are the best practices? That's going to make you a better coder in the long run.
That's a good point. So, okay, let's jump in. One of the first things he does is he kind of lays out the case for why Python. It's not just about the cool features, is it?
No, not at all.
There's something, I don't know, he just feels like a wise, caring guide.
Yeah. You really get that sense that he wants you to succeed
Mm-hmm.
and not just write code that like technically works, but code that is good.
Well written, yeah.
Well-written, readable,
Maintainable.
maintainable, all that. That's huge when you're just starting out.
It is. And he really gets across just how much you can do with Python. We kind of touched on it.
I mean, the range is incredible.
Yeah. You can build websites. You can analyze tons of data.
ETL, data pipelines.
Yeah, even just moving data around.
Yeah.
It's quite impressive.
And this part was really interesting to me. He talks about Python as this glue agent.
Okay, I like that.
So you think about it, in companies, you often have different systems
Right.
built with different languages,
Of course, yeah.
and they need to be able to talk to each other.
Right? They got to work together.
Python is often fantastic at that. It's like the translator.
Oh, okay.
It lets those systems, even if they're using different languages, work together. So even if a company's main language isn't Python,
Right.
it might still use it to connect the pieces.
That makes a lot of sense.
And he also brings up something that's really important, I think. A lot of people think coding is this really dry, technical thing.
Yeah.
But he actually emphasizes that Python can be fun.
That's surprising.
Yeah, and he means it. He argues that when coding is fun, it makes you more motivated and more productive.
I buy that. When you're using tools that feel good,
Mm-hmm.
it makes a huge difference.
For sure. When the tools are intuitive and the language is designed well, like he points out with Python's data structures, the whole process is just more enjoyable,
Yeah.
and that keeps you going.
Keeps you going, yeah. Now, no language is perfect. And he does touch on a potential downside. Speed.
Right. Compared to some other languages, Python can be a little slower. It has to do with how it's executed. See, when you run Python code, It's not directly translated into the machine's language.
Right.
It first goes through this intermediate step where it's turned into something called bytecode.
Okay.
And then another program called an interpreter actually runs that bytecode. This extra step, it's what makes Python so portable, meaning it can run on lots of different systems.
Ah, that makes sense.
But it does make it a bit slower than languages that are compiled directly into machine instructions.
Okay, so say you're sold, you think Python's the way to go. Where do you even start?
Right.
He walks you through that, right? That initial setup.
Yeah, he does. The easiest way, he says, is often to just open up your terminal or command prompt
Okay.
and just type Python. And that launches what's called an interactive shell. It's like a little sandbox where you can type commands and immediately see what they do.
So just play around.
Yeah. It's great for experimenting and getting a feel for the language.
Perfect for beginners.
Absolutely.
Yeah.
Now, he also mentions IDLE, which is a little more, I guess, user-friendly for beginners.
Okay.
It's what's called an integrated development environment. So you've got a text editor to write your code,
Yeah.
and then you've got that shell built right in, all in one window.
Nice. So it's all there.
Yeah. And then another thing he really emphasizes is virtual environments.
Oh, yeah. Virtual and Orvry.
Exactly. Virtual and Orvy. And this is so important as you start working on multiple projects.
Okay, why is that?
Well, imagine you have two projects, and they both use the same library but need different versions of it.
Oh.
Yet without virtual environments, installing the library for one project might break the other one.
Oh, I see the problem.
Virtual environments create these isolated spaces, like separate sandboxes for each project. Each one can have its own set of tools and libraries without interfering with the others.
Oh, that's really clever. So it's kind of like having different toolboxes for different jobs.
Exactly.
Now, early on, he introduces some really important best practices. And one of those is the DRY principle. What is that all about?
Don't repeat yourself. It's a core idea in programming. If you find yourself writing the same chunk of code over and over,
Yeah, you're probably doing something wrong.
yeah, there's probably a better way. He says you should try to encapsulate that code in a single place and reuse it. And that has a couple of benefits. First, it makes your code much easier to maintain.
Because you're only changing it in one place.
Exactly. If there's a bug or you need to make an update, you only have to do it once.
Makes sense.
And second, it helps you avoid inconsistencies.
Yeah, because you're not accidentally introducing subtle differences across different parts of your code.
Exactly.
Now, another thing he mentions is this idea of writing Pythonic code. It's a term you hear a lot.
Yeah.
What does that actually mean in practice?
So it's all about writing code that not only works, but is clear, concise, and readable.
And feels natural, I guess.
Yeah, it should feel natural to someone who knows Python. It often involves using Python's built-in features the way they were intended, like using list comprehensions, for example, which are very Pythonic. He also mentions PEP.
Okay, what's that?
PEP8 is the official style guide for Python code. It's like having a set of agreed-upon grammar and punctuation rules for your code.
Oh, so everyone's on the same page.
Exactly. It helps ensure consistency across different Python projects.
So it makes it easier for other people and even your future self
Right.
to understand your code.
Makes total sense.
And then he brings up a concept that's very core to Python, and that is everything is an object.
It sounds a bit abstract, but it's fundamental.
It does sound abstract, so what does it mean?
So in Python, anything, a number, some text, a list, even a function, they're all treated as objects.
Okay.
This means they have associated data, what we call attributes, and things they can do, which are called methods.
So it's not just the data itself. It's
Right.
the data plus what you can do with it.
Exactly. Yeah, and understanding this idea helps you understand how all the different pieces of Python fit together.
Okay, let's talk about data types. Now, it's not just about having different ways to store your information.
It's more nuanced than that.
Yeah, each one has its own strengths, I guess.
Yeah, for sure. They have their own purposes.
Yeah.
And using the right one can really impact how smoothly your code runs.
Right.
So first up, we have numbers, basic arithmetic, addition, subtraction, all that. But Romano highlights a really important distinction.
Okay, what's that?
The difference between true division and integer division. True division, you use a single forward slash.
Oh, okay.
And with integer division, you use a double forward slash.
Right, and that can be confusing for people who are used to older versions of Python.
Absolutely. The behavior changed between Python 2 and Python 3.
And he also mentions the decimal module. Right. When would you use that?
The decimal module, it's fascinating. It lets you do calculations with arbitrary precision. So if you need to be super accurate, like in financial calculations or even tiny rounding errors can be a big deal.
Yeah, you don't want to mess with money.
Exactly.
Yeah.
The decimal module lets you define exactly how precise you need to be. It's like having a super accurate ruler.
Hmm.
But he does mention it comes with a bit of a performance cost compared to regular floating point numbers.
Okay, so trade-offs, right. Then we have sequences,
Yeah.
lists, tuples, strings.
Yeah. Those are all about storing ordered collections of items.
So the order you put things in matters.
Exactly. Now, lists are mutable. You can change them after you create them, add stuff, remove stuff.
Flexible.
Very flexible. Tuples, on the other hand, they're immutable. Once you create them, they're set.
Okay.
Strings are also immutable. They're sequences of characters. And he talks about slicing and indexing as ways to access specific elements within those sequences.
Yep.
And even negative indexing, which is really cool. It lets you grab elements from the end of a sequence. And he even mentions that you can use slicing for assignment in lists.
Okay, so like replacing a whole section.
Yeah. But he notes that it's not something you see super often in professional code.
Interesting. So then we have sets and frozen sets.
Right. Those are for collections where every element has to be unique.
No duplicates.
Exactly. No
Yeah.
duplicates. Now, sets are mutable. You can add and remove elements.
Okay.
But frozen sets, they're the immutable counterpart. Once you create one, it's fixed. And that might seem limiting, but it's actually super useful when you need a set that can be used as a key in a dictionary, for example, because dictionary keys have to be immutable.
Right.
Both sets and frozen sets are optimized for tasks like checking if an element exists, finding the union, intersection, or difference between sets, all those set operations.
Then we get to what Romano calls the most interesting mapping type, dictionaries.
Oh, yeah?
He even says they're the backbone of every Python object.
They're incredibly important. So a dictionary, it stores data as key value pairs. You can think of it like a real dictionary.
Definition.
Exactly. You use the word, which is the key, to look up the definition, which is the value. Now, the keys in a dictionary, they have to be hashable. It basically means unique and unchanging.
Right.
That allows Python to quickly find the value associated with a given key. He shows all sorts of ways to create dictionaries, and he highlights the zip function.
Oh, that's a handy one.
Super handy. It lets you combine two sequences, say a list of names and a list of ages, and create a dictionary where the names are the keys and the ages are the values. And another important point, since Python 3.6, dictionaries preserve the order in which you insert items.
Oh, that's
So
cool.
they're even more useful. And then he introduces the set default method.
Now, what's that for?
It's for those cases where you want to add a key to a dictionary only if it doesn't already exist.
Okay.
And you want to set a default value if you do add it. It just makes your code a bit cleaner in those situations.
I see. So beyond these kind of core data types, he mentions the collections module.
Right. Specifically, he talks about name tuple and enum.
Now, when would you use those?
Name tuple. It's basically a way to make your tuples more readable. With regular tuples, you access elements by their index, like 0 for the first element, 1 for the second, and so on.
Okay.
With name tuple, you can give names to each position in the tuple.
Okay.
So you can access them like mytuple.name or mytuple.age.
Much more readable.
Yeah, it makes your code much clearer. Now, enum is for creating enumerations.
Hmm.
Think of it like defining a set of symbolic names that represent specific values.
Like days of the week.
Exactly. Or status codes for a web request. Using enum makes your code more self-documenting and avoids those magic numbers or strings that can be confusing.
And at the end of this section, he really stresses the importance of picking the right data structure.
Yeah, it's not just about can you store your data in this structure,
Right.
but which one makes your code the clearest and most efficient.
Mm-hmm.
He suggests that if your code is feeling overly complex, it might be a sign that you haven't chosen the most appropriate data structure.
You're fighting against it.
Exactly. It's about making your code flow naturally with the data it's working with.
Okay, so now you've got your data organized, but you need to tell your program what to do with it.
That's where controlling the flow comes in.
Right, the logic of the program.
Loops, conditional statements, all that.
So let's start with loops.
He covers 4 loops, which are great for iterating over sequences, like going through each element in the list.
Yeah.
And he highlights the enumerate function,
Oh, yeah, that's a good one.
which is super handy when you need both the index of an element and the element itself as you're looping. Much cleaner than keeping track of the index manually.
Right.
He also covers while loops, which run as long as a certain condition's true.
And he makes a good point that anything you can do with a for loop, you can also do with a while loop.
You can, yeah.
But often the for loop is more concise and easier to understand if you're working with sequences.
Makes sense.
Then we have conditional statements. If, elif, and else. These let your program make decisions based on whether certain conditions are true or false.
The core of logic right there.
Yeah.
And then things get really interesting with comprehensions.
Oh, those are so cool.
Right. You've got list comprehensions, dictionary comprehensions, set comprehensions. There's such an elegant and powerful way to create these data structures in Python.
Yeah, instead of writing a whole for loop, you can often do it in one line.
Yeah, in a very readable way.
Yeah.
He actually compares them to using map and filter and argues that comprehensions are usually much clearer.
They just make sense.
And they're not just for simple things. You can include conditions within a comprehension to filter elements as you create the new list or dictionary or set.
Really powerful.
Super powerful. Now, to really think about efficiency, we have generators.
Ah, yes. And those use the yield keyword, right?
Exactly. Yield in a function makes it a generator function. You can also have generator expressions. And they're very memory efficient. When you create a list, the whole thing is stored in memory. But with a generator, it doesn't do that. It just defines the rules for how to produce the next item.
It's lazy.
It's lazy, yeah. And it only creates that item when you ask for it. This is amazing when you have huge data sets.
That might not even fit in memory all at once.
Exactly. Or even like infinite sequences.
Whoa.
He also shows how using generators with functions like sum can save you a ton of memory compared to using a list comprehension.
Oh, that's cool. And then there's the itertools module.
Oh yeah, that's like a treasure trove of pre-built iterators. Things like permutations that generate all possible orderings of a sequence.
But he does warn you got to be careful with those.
Yeah, factorial growth can get out of hand really quickly, but it is a really powerful module for manipulating sequences and data.
Okay, so you've got your data, you know how to make it flow. Now, how do you organize your code into reusable chunks so you don't have to keep writing the same thing over and over?
Functions.
Functions, right.
The building blocks of well-structured code.
And what are some of the benefits of using functions?
He lists several. First, you avoid repetition.
DRY principle?
Right there.
Fair.
Second, you can break down complex tasks into smaller, more manageable pieces.
Divide and conquer.
Exactly.
Yeah.
It helps you think more clearly about your program. Third, you can hide the details of how things work, making your code cleaner at a higher level.
Abstraction. Yep.
Exactly. And finally, functions make your code more readable and easier to trace.
Easier to debug, too.
Oh yeah, definitely. He also covers the different ways you can pass data into functions.
Arguments.
Right, arguments.
Ah.
You've got positional arguments, keyword arguments, and then the flexible ones with args and quarks to catch any extra arguments. And there's this interesting point he makes about mutable default arguments.
Okay, what's that?
So if you use a list or a dictionary as a default value for a function parameter,
Okay.
that same object is shared across multiple calls to the function.
Oh, so it's not creating a new one each time?
No. And that can lead to weird behavior because changes you make in one call stick around for the next call.
Gotcha. So the best practice is to use none as the default and then create the list or dictionary inside the function if you need it.
Exactly.
Now, he also talks about the importance of having consistent return types from functions.
Meaning that if a function returns a list sometimes,
Right.
it shouldn't return a number other times. It should always return the same type of data. Makes your code more predictable.
And this idea of minimizing side effects.
Oh, important. Ideally, your functions shouldn't be modifying things outside of their scope.
It's all about clarity and predictability.
Exactly. You want to know exactly what a function's doing just by looking at its input and output.
So then he gets into things like anonymous functions with lambda.
Those little throwaway functions.
Right. Recursive functions that call themselves.
Which can be really powerful.
And docstrings for documenting your code.
Essential.
And then, of course, how to use those functions by importing them from modules.
The glue that holds your project together.
So, okay, I've got the basics down. How do you start making your Python code run faster and more efficiently? That's what the chapter on saving time and memory is all about.
Optimization.
Optimization, right. He revisits those map, zip, and filter functions, which can be a bit more concise than using loops sometimes.
Yeah,
But he seems to favor comprehensions in a lot of cases.
he does. Comprehensions often lead to more readable and often more efficient code.
They're just so elegant.
They really are. And he talks about generators again, stressing their memory efficiency, especially when you're dealing with large data sets.
Because you're not loading everything into memory at once.
Exactly. You're processing it bit by bit as needed. He also mentioned some general performance considerations, like don't over-optimize at the cost of readability.
Right, there's a balance.
Always. And he touches on this cool thing called name localization that Python does to make lookups faster.
decorators, iterators.
Oh yeah, fun stuff. Let's start with decorators. They can seem a bit mysterious at first,
A little bit, yeah.
but they're really just a way to add functionality to your functions without directly changing the function's code itself.
You're decorating it, wrapping it up.
Exactly. It's like adding a GIF wrapping layer around your function.
I like that. Now, object-oriented programming.
That's a big one. It's a whole different way of thinking about code. It's about structuring your code around objects, which have data and behaviors.
So it's not just a sequence of instructions anymore.
Right. You're defining these blueprints called classes, and then you create objects from those blueprints.
Objects that represent things in the real world or concepts.
Exactly. And the objects have attributes, which are their data, and methods, which are the actions they can perform.
So it's data plus behavior.
Right on. And one of the big advantages of OOP is code reusability. You can achieve this through inheritance and composition.
So inheritance is a relationship, right?
Exactly. One class inherits characteristics from another class.
Like a subclass.
Yeah. And composition is the has-a relationship. An object is made up of other objects.
Okay.
He also gets into multiple inheritance.
Where a class can inherit from more than one parent class.
Exactly. And how Python determines which method to use when you have this kind of inheritance hierarchy.
Sounds tricky.
It can be. He uses a classic example with classes named D, B, C, and A to illustrate how the method resolution order works in Python.
Then he talks about class methods and static methods.
Different ways of associating functions with a class,
Right.
and then the conventions around private methods using underscores.
Yeah, to signal that they're for internal use only.
Exactly. And the property decorator.
Oh, that's a handy one.
Super handy. It lets you control how attributes are accessed and modified.
Without breaking the interface.
Exactly. You can add validation, calculations, all sorts of things behind the scenes.
And he even mentions operator overloading, so you can define how operators like plus and minus work on your objects.
Yeah, and polymorphism, which means that you can use the same code to operate on different types of objects. And finally, he talks about data classes, which are a nice shorthand for defining simple data holding classes.
So what about when your program needs to interact with the outside world, like reading and writing files? That's what the chapter on files and data persistence is all about.
Right, essential stuff. He starts with the basics of opening, reading, and writing files, and he really emphasizes using the with open statement.
Which ensures the file is closed properly, even if something goes wrong.
Yeah, prevents data loss. And then he talks about the os.path module.
Oh, that's a good one.
It's got all these functions for working with file paths in a way that's consistent across different operating systems.
So you don't have to worry about whether you're on Windows or Mac or Linux.
Exactly. And he mentions temporary files and directories.
Useful for testing. Yeah.
And then, of course, JSON.
Oh, yeah, that's the language of the web.
Pretty much.
He explains how to encode Python data into JSON and how to decode JSON back into Python objects.
And the requests library for making HTTP requests.
Super important for interacting with web APIs.
Definitely.
And then he gives a really nice introduction to relational databases and SQL.
The foundation of so much data storage.
He explains the basic ideas and then introduces SQL alchemy, which is an OR-ARM.
What does an ORM do?
It lets you interact with the database using Python objects instead of writing raw SQL queries.
So it's a more Pythonic way to work with databases.
Exactly. He also briefly mentions pickle and shelve for serializing Python objects directly to files.
Now, once you've written all this code, how do you make sure it actually works?
Testing?
Testing, right. It's not an afterthought, is it?
Definitely not. He emphasizes that testing should be an integral part of the development process.
Why is that? Testing helps ensure your code is correct. It catches those weird edge cases, verifies performance, and makes it easier to change your code later on without breaking things.
Right, because you have those tests to fall back on.
Exactly. He talks about different types of tests, from small unit tests to broader integration tests, and he gives practical tips for writing good tests.
Keep them simple, focused, fast.
Exactly. And he mentions PyTest, which is a popular testing framework in Python, and he explained how to handle exceptions gracefully.
Exceptions, those are the errors that can pop up while your program is running.
Right. He shows you how to use try, except else, and finally blocks to deal with them so your program doesn't crash. And he stresses the importance of being specific in your except clauses.
Only catching the types of errors you expect.
Yeah. And he even shows you how to create your own custom exception classes.
So you can be more expressive about the types of errors that might occur in your program.
Exactly. He also touches on the hashlib module for creating secure hashes.
Important for security.
and JWTs, which are used a lot for authentication and authorization.
Those are JSON web tokens, right?
Yeah, he explains their structure and even gives examples of how to create and decode them.
So what about when you want to do multiple things at the same time in your Python program? That's concurrency, right?
Yeah, it can seem a bit daunting, but he does a good job of introducing the key ideas. He talks about the GIL, the global interpreter lock.
Right, which can sometimes limit true parallelism.
It can. He shows how to create threads using thread, and he points out that threads don't always run in a predictable order.
Yeah, they can kind of do their own thing.
Right, and then he gets into race conditions.
Those are nasty.
Yeah, they can be hard to debug. He explains how using locks can prevent those race conditions. And he talks about multiprocessing, which uses separate processes instead of threads, and can sometimes be a better way to achieve parallelism.
And he touches on how threads and processes can communicate with each other using queues.
Important for coordination.
And thread and process pools for managing multiple workers.
And even a brief intro to Asyncio, which is a more advanced way to achieve concurrency using coroutines.
Okay, so you're bound to run into bugs, right?
Happens to the best of us.
And he's got a whole chapter on debugging and troubleshooting.
Essential skills. He shows how to use the time module to find performance bottlenecks,
Okay.
how to read those traceback messages you get when an error occurs, how to use the Python debugger, PDB, to step through your code, and the power of logging to record what's happening in your program.
And assert statements for checking conditions.
Super useful. He even mentions binary search as a technique for finding bugs. And he reminds us that well-written tests can be super helpful for debugging.
He even includes chapters on creating graphical user interfaces, GUIs, and writing standalone scripts.
Yeah. He walks through a practical example of a script that scrapes images from a web page.
Oh, cool.
And then he introduces Tkinter, which is Python's built-in GUI library.
So you can create those interactive windows and buttons and stuff.
Exactly. He shows how to create a simple GUI application with all those basic elements. And then the final two chapters are these whirlwind tours of data science and web development with Python.